Video is a quick introduction for the gamma function, so it's very quick. So I think I will just prove the most important properties of gamma function and tell you some values about the gamma function and try to explain it. So maybe I think it's not very difficult. Okay, so this is the gamma function definition. Gamma x is equals to let me use z. So this is minus t to the z minus 1 dt. Okay, so this is the gamma function. Okay, so the first property everybody should know is that the gamma z plus 1 is just z gamma z. Okay, so this is the first properties you need to remember. Probably the most important properties. Okay, so let me quickly give you a proof. Okay, so the proof is just directly compute. You get the t to the z dt. And then how do we do this? Then you just use the so-called integration by part. So you can, let me see. Okay, we should use this as this is u, this is dv. So we get the u times v minus this and du. So du is this. Okay. So this is 0. So you get 0 to infinity exponential minus t z t z minus 1 dt. So this is z gamma z. Okay, so this is the definition. So very simple. Okay, and then next we say the gamma 1 just infinity 0 to infinity exponential minus t to the z minus 1. So it's d dt. So this is 0 to infinity exponential minus t dt. And I think this is very standard. Infinity put is 0, 0 put in is minus 1, so that's 1. Okay, so this tells you that gamma 2 is just 1 times 1 is, which is 1. Gamma 3 is just 2 times gamma 2, which is 2. And the gamma 4 is just 3 times gamma 3, which is 6. Okay, so obviously gamma n, when n is the positive integer larger than 1, should be n minus 1 factorial. So this is another important properties. Okay, so you can view that the gamma function generalize the factorial. So I can say that the n factorial I define to be gamma n plus 1. And this n can be viewed as a whole complex number except for some values which we will discuss later. Basically is the negative integer, 0 and the negative integer. Okay, and then another properties is that gamma 1 over half. Okay, so gamma 1 over half is square root of pi. Okay, and to prove it, what we need to know is that this Gaussian integral is basically square root of pi divided by 2. Okay, so you need to remember this. Okay, so let me go back to our original gamma function. So this is the definition. Okay, so we can let t just equals to some r squared. So get 0 to infinity exponential minus r squared, and r squared r to z minus 2 dt is just 2r dr. Okay, so what we have is 0 to infinity 2 exponential minus r squared exponent r to the 2z minus 1 dr. So if gamma z is just 2 this, so this is another integral representation, which call it like this. Okay, so gamma 1 over 2 just 2 times 0 to infinity exponential r squared r0 dr. So this is 2 times 0 to infinity exponential r squared dr. So this is 2 times square root divided by 2, which is pi. Okay, so this is the another properties for the gamma function. And you can see my other videos. There are plenty application of gamma function. The most important property is the n-dimensional sphere, the volume of the volume and the surface area of a dimensional sphere. Okay, and I think let me collect what we have learned today. So what we have proved is that the gamma n plus 1 is just n gamma n, and and also we know that when n is larger than 1, equal to 1, then gamma n just n minus 1 factorial. And we also proved that the gamma half is just square root of pi. Okay, so you also show this is this gamma 3 over 2 is just square root of pi divided by 2. Okay, so this is the first properties of the gamma function, and I will see you guys in other interesting videos, and be sure to subscribe to my channel.